A homeowner is worried about the work needed to maintain a grass lawn and flower beds, so she is now looking at some low-maintenance materials. She is considering artificial turf, which costs $15 per square foot to install, and gravel, which costs $3 per square foot. She may use a combination of the two materials in different parts of the yard. Her budget is $3,000. This graph represents some of the constraints in the problem. This graph goes through the point 500, 100. What does this point mean? The point is on the line, and the line represents the budget of $3,000. So she can order 500 square feet of gravel and 100 square feet of artificial turf and stay at the $3,000 budget. Write an equation of the line. You know that the gravel is on the x-axis and costs $3 per square foot. The cost of gravel is represented by 3x in an equation. The cost of the artificial turf is $15 per square foot. This is represented by 15y. So together, 3x plus 15y equals 3,000 is the equation for the line. What do the solutions to this equation mean? Any point, xy, that is a solution would be a combination of artificial turf and gravel that will cost $3,000. The point 600, 200 is above the line. Does it meet the owner's constraints? Since it is above the line, it is above the $3,000 budget. The point 200, 100 is below the line. Does it meet the owner's constraints? Since the point is below the line, it is below the $3,000 budget and meets the constraints. The point 250, 150 is on the line 3x plus 15y equals 3,000. Substitute 250 in for x and 150 in for y. The equation, when simplified, is 150 equals 150, so the point is a solution to the equation. The point meets the constraints. Write an inequality that represents the constraints in the situation. The sum of the gravel and turf must be no more than the budget of $3,000, so 3x plus 15y is less than or equal to $3,000. To see this on the graph, all points on or below the line will be solutions that meet the constraint.